Okay, I think we're live now. Hello, hello. Hello, everyone. This is day 29 of... I think it's 29. I hope I'm counting correctly. This is day 29 of studying compilers every day until I land a compiler rule. Yeah, I guess it's just a little bit of the same, a little bit of change here and there. Yeah, I'll do the LeetCode daily, and then last night I decided 3 a.m. was a really good time for me to build out testing infrastructure a little bit more. So I spent way too much time on it, but there's some stuff that's been pushed to GitHub, and I figured it at least makes sense to catch up on that and also look at it with a fresh pair of eyes, especially since I was a little bit sleep deprived when I was writing all that code. And then finally, the actual piece of work I want to get done today is trying to look at implementing middle end passes, because that is where the fun stuff lives. What's good, John? Good to see you today. LeetCode. Practice time. On day 1, one person discovers a secret. Okay. This is pretty funny. So you're given an integer delay, which means that every person will share the secret with a new person every day, starting from n days after discovering. Integer forget, which means they will forget the secret after that, and they can't share after. Okay, interesting. Oh, we have to modulo. Great. This is pretty funny. You should write a SQL database. That would be cool. That might be something I look at. Databases are like a whole nother can of worms, and I'm a little bit scared to open that can of worms. I might take the databases class Northwestern offers. That might be interesting. There's just like a lot of stuff going on in the backend that's like really cool, but I've just been scared off from the class for a while at least. So, yeah, we'll see what happens. I guess if I can like throw it onto undergrad, if I throw it onto undergrad, any GPA tank is like whatever, huh? So, yeah, okay. People aware of secret. How do we manage this? This is really annoying, actually. It's a really interesting problem. So day 1 is the first day. Okay. Or day 1 n is 1. Or I guess the number of people that know is 1. How do I tackle this? Let's just try straight up simulating it, I guess. I don't think that hurts yet. We can let's make the const thing first. Oh, this is in Python. Wait, the hell? There we go. We want const expr mod equals 10 e9 plus 7. Do that. Yeah, so I guess we could just try simulating it for now. I think that's probably a good start. I'm scared of like memory here. Because I imagine this can scale quite quickly, and I don't really have a good way to track the number of days each person can contribute, I think. So I'm gonna use the hint. This is 2DDP. I see. Well, crap. Okay. Well, okay, that completely changes the way I look at the problem, actually. Okay. That sucks. That really sucks. Someday, okay, I guess that kind of makes sense. Vector, int, dp, this is, so I will be the day, so we have n, and then what size should this one be? This should be forget, I think. J plus 1 days. Whereas compiler, I need to, part of this whole thing is becoming employed. So there is a little bit of LeetCode that needs to be done inevitably. But I guarantee I will get to compiler stuff within half an hour to an hour. So then forget is the ceiling here? I think let's do that for now. If I run into a problem, I'll change that. And then dp at 0, 0 is 1, I guess. So then you can just iterate across this like this. Let's see. This is a little bit interesting, actually. So forget is the day that they forget it, or days after discovering it. So we need forget plus 1, I think. Right? No. No, we don't, because yeah, okay. So we can iterate from delay to forget, I guess. J equals delay, J less than forget, J plus plus. So then also I should be 1. So then we have dp at ij equals dp at I minus 1, and then j minus 1. Oh wait, no, we need to. This can't be delay. We need to add this if it's delay. J is greater than equal delay. Yeah, this makes sense. Then we want to. Let's get prev, I guess. Or I guess int cur equals that. And then it should be J should not be delayed. This should be 1 as well. We want int new people equals 0. And then if it's greater than equal to delay, then they will tell someone the secret. So we would need to add new people. So new people we will add cur to. And then we can just set this to cur, I think. And that should be good. Oh, we need to add new people. DP at I0 equals new people. Turn DP at, we want n-1, forget -1, right? Oh wait, we need to accumulate on. Okay, yeah. We need to accumulate on the DPN. I also just realized I need to do mod. So new people is new people plus cur. We can do this. Mod, do that. We can't do this. We have to plus equals I return res. Let's give this a try. Static. Oh, what's good, MD? Welcome back. Static long. What's going wrong here? Oh. This is a comma. N-1. Okay. Oh, okay. Okay, we need to address that one. Let's move this parenthesis over here, I think. This should be correct still? I don't think this will overflow. Oh, I need to do it here as well. Equals long res plus I mod. And oh, come on. If you're stuck on an island and you could choose only one data structure to have with you, what would you choose? I would... I would choose a poorly implemented version of a linked list because there will probably be a memory leak, and that means it will grow so long that I will have a bridge that will get me off the island. Let's see, what is going on? I don't think I need to long this, right? No, I need to... why is this going wrong? This should be a long, right? You can skip this even. You can get rid of this cast. Right. Yeah, it's still wrong. MDM not replying because I'm taken and I'm in a relationship. So this has to be a rounding issue, right? Why is this going wrong? So, this should still be an int, right? Oh, wait, that's not what it's supposed to be. Wait a second. Okay, we got it. And it's really slow. Oh crap, why is it really slow? Oh, because I'm doing it 2D. Why am I doing it 2D? Why don't I need to do it 2D? Oh, okay, I see. Because we literally have the numbers from I see. Yeah, that'd be way faster. So let me... No editorial yet, bruh. So surely there's like a faster way to... Poor guy. Yeah. I really overcomplicated this, but yeah. I'm not gonna try and do the 1D DP right now. I might do that off stream afterwards. How do you manage to not exhaust yourself mentally trying to balance college, work, and studying for a role? I'm a CE student doing an internship, and I feel like I'd go insane if I grind LeetCode. I think the big thing is kind of just like not forcing anything. Like for me, I feel like I try to at least enjoy what I'm doing. So I guess this isn't like necessarily the most helpful advice, but like if you're really not feeling something, then I don't think it's really productive to push it and to try and sort of force yourself to do it. But it's a lot of just like time management as well. Like some things, like if you need to get something done, or it's just like sequencing, I guess, if that makes sense. And like sometimes some things have to get cut from the list. Like when I like flew back to campus, for instance, I took the day off from streaming for that, because I was like tired as hell and I wanted to say hi to people. So it was just like prioritization at the end of the day. I think in terms of like priorities, I think college is like still top because I need to like worry about graduating. I guess like work and college are sort of the same level. I feel like at least like for now, if I'm like having one, I don't really have the other to worry about in the moment. And then from there, it's like personal projects slash LeetCode slash like other general interview prep would be like another tier. And then I think like between the two, I would put like research. So a lot of the decisions are like very just vibes based, very like on the fly, depending on what I'm feeling. I'm not sure if that really answers your question, but hopefully that at least gives you some direction. Oh, I moved my screen. 1 second. Okay, cool. So we got LeetCode done. We take those. So yeah. Yeah, of course. So last night I spent a little bit longer than I should have just continuing the stuff I did in the day. So there's a little bit of a mess in here. We can ignore this one, but I merged the test branch after doing a little bit of other stuff. So I fought with my codegen for a while because there was like this really annoying situation where like the way generated functions and basic blocks, I wanted there to only be like an empty line between them. So the way I had it previously was just like after each function I just append a new line. But then I realized like that's not what I wanted, so then in MIR codegen I made it so the first one, or like the first function or first basic block isn't prepended with not prepended with like a double new line, but then every single one after that is prepended with it. So then like that creates like a one new line gap between them. But then that was like doing a weird thing where even though it was like prepending new lines, the file being read ended up having a new line appended, which was like really confusing. I didn't really know what was happening. So I spent like an hour or two just fighting that. I like crashed out at ChatGPT. That was funny, but I ended up just making them all consistent and called it a day. And then I built out the test runner a little bit more. I guess I can show that real quick. That was here. I have a third window. Yeah, so it was in tests. I moved everything into regression and unit tests because I want to write unit tests eventually, but for now I don't really feel like it. But regression is nice because then I can just I can just pump in like input files and then I can compare them against expected outputs that I'm generating from it. So that's like a nice little thing that I can do. I haven't implemented like the test outputs for this yet, but this might be like, I feel like I'll just like build this out slowly as I decide to procrastinate on schoolwork as the year goes on. The CMake list slush for this I think is a little bit interesting. I moved the test CMake stuff to its own thing, and I also found out the hard way that you need enable testing in the root CMake root CMake list because it wasn't picking up the tests otherwise. So then going into here, this one has the fetch content, and then it adds the subdirectories. Yeah, this is like the standard like adding an executable stuff, include gtest stuff. Yeah. So that's that, and then the runner has a couple of changes. It pretty much just has like 3 tests per file right now, and each of these just compiles down to whichever specific state it's looking for, and then just compare against the file. It's not too much interesting. There was like a little bit of annoying slush here and there. I guess the only like minorly interesting thing is that it also handles like if a file is missing, because sometimes I don't have it implemented yet. So now if we make test, it should run the tests. Yeah. So it runs them and then it vomits out all the skipped ones. So yeah, sure. Yeah. So that's like the big test pile. What else did I change? Oh, the regression tests, it caught a bug when I was I was messing around with the new line stuff. It caught a bug that I introduced, which was really funny. So yeah, that's most of it. The only other thing is I added like GitHub Actions for automatically running tests, but I did it wrong here, so then I like and then I rebased the branch, so that like created a mess. So I just made a new branch and called it a day. And yeah, now it runs tests. So yippee, that's automated. That's like the big pile done. From here I can just like slowly trickle stuff into there. When did you decide the compiler's weird thing? Was there a moment that clicked? It was mostly the compiler's class I took in my winter quarter of sophomore year. So the initially the way I got into it was I was taking our programming languages class, and one of my friends was like, "Oh, hey, this compiler's class exists. You should look at the course evals because I've never seen something so brutal." So I looked at it, and it was like all like I think a solid like 40 out of 40 of the comments were just like, "This class is 20 hours of work a week, but it is also the best class I have ever taken." So that was a little bit intimidating, but then I got into it. Or I guess like the reason I ended up taking it was because it was kind of like a I'll take it if you take it sort of decision. And then in the moment, it was like really cool, and I was like, "Oh, these systems are really cool. These are really complex." And then like halfway through, I'm like pulling all-nighters here and there just to like get the work done, and it's like awful. And then like after I'm through it, I look back in hindsight and I was like, that was cool. I'm gonna do compilers research. So that's what I've been doing since then. How old are you? How did you become so smart? Thinking to start streaming too and talk to myself so I improve my English and also have the motivation to stay disciplined. Well, you can probably infer my age roughly just from the fact I'm going into my 4th year of university. I wouldn't call myself smart. There's just a lot that I have to learn still, but I have a lot of like background to draw from at least. It's just like a lot of looking for things and trying to become a subject matter expert pretty much. The one thing I've learned about or from streaming is just like it's honestly less scary than I initially expected. There is on one hand a sort of fear of talking to just like a general audience, which is present just because I also want to merge this branch while I'm talking. There's like a general fear of just like talking to a bunch of people that you don't really know, but at the end of the day, like everyone so far has been pretty kind, and everyone seems pretty genuine at least. I hope nobody takes advantage of that, but yeah. So we can delete this branch, and then we can make a new branch, I think. How old are you? You can definitely figure that out. So yeah, that's that addressed. So now we can start the PaaS infrastructure stuff. Yeah, let's go to the correct place. So the idea I'm having right now, I guess I will just draw out the good old compiler diagram. So we distinctly have 3 phases to the compiler. We have the front end, we have the middle end, or optimizer, and then the back end. So the idea is we have C code here, we pass it into an optimizer language, which is MIR, and then from here we can like do some sort of code gen to get like assembly. And then this is made up like multiple stages. There's like a parser, and that makes like AST, which is the abstract syntax tree. And then there's like a little desugaring step, and then that makes this thing called HIR, which I made up. So this is like sort of simplifying or reducing the instructions that are there, and also like getting rid of like scopes, so all variables become sort of unique and handle shadowing appropriately. So I'll just call this desugar. Will it support multiple platforms? The build itself should be, or at least the build itself I've tried to make as platform agnostic as possible. And the idea is, since we have this one unified middle language, we can, in theory, just write more compilers from different languages. So like Go, for instance, or like Rust. And then we can also target other backends as well. So like ARM, and then this is like x86. And this is like the usual like compiler spiel I give. But there's one thing that's been missing so far, and the thing that's missing here is the optimization step. Opt, I guess I will call it. And that's like the big thing that the middle end handles. Just to divide this, I will like do this roughly as an example. So I've been thinking a little bit about how I want to implement this, and the big question is like, so in general, like I've been like looking at llvm just for like most of my inspiration, and the idea is to like kind of re-implement it, or at least understand its design choices. So what it has is it has this thing called a pass manager. Yeah, we'll just zoom in like somewhere here. Pass. So okay, so I should back up a step. So pass is like a program run on, I guess, a snapshot of this MIR. And that either generates like information that optimization passes can use, and that pass is called an analysis pass, or it's a transform pass, which I guess attempts to make a optimization or some change to the MIR. So if it makes changes, then it's a transform pass. If it just tries to gain info, then it's a analysis pass. That's what it's called. Yeah. So but then there's like this problem of like which passes should be run in which order, and then you also have the issue of like if a transform is made, you need to like rebuild the analysis passes because the code has like changed in some way. So llvm has this thing called the pass manager. Pardon my mouse scribbled handwriting. So they have this thing called a pass manager, and that sort of accumulates the passes that need to be run and the order they need to be run in. And this also lets you like, you can sort of like build this up yourself. I'm like 90% sure I'm correct about most of this, by the way. If anyone notices something I'm just like completely getting wrong, please let me know in the chat. But I think this is like a rough high level explanation of what I'm trying to make. So this thing sort of like determines the order the passes are run in, and then it I guess it literally manages them. So yeah, I guess that falls into there somewhere. And then like this loop runs until everything's done, and then it gets shipped off to the backend to handle. The biggest design decision I've thought about so far is if we want each transform pass to generate a brand new MIR memory object, or if we want it to just mutate the existing one. I think my plan for now is to make it mutate the existing one, because low-key making copies is kind of expensive, and it also makes a little bit of a mess out of like analysis passes. I guess like the worst case scenario is like the only downside for making it mutate in place is that I would need to write more like setters and getters for MIR, which is like fine. That's like something I tried to avoid, but that is like kind of roughly that is something that I will have to reconcile probably today, actually. So it'd be faster? Yes, in theory it would be faster. How long did it take you to get so good at LeetCode? I'm not particularly great at it. I think the biggest things that helped me were first doing some combination of like NeetCode 150 and Blind 75. I only got through like a third of it because I was low-key kind of a bum last year. But that at least helped me a lot in terms of like getting used to the basic patterns. And then the second thing was just the algorithms course I took. I think it was 2 years ago. That got me sort of acclimated to greedy problems, backtracking problems, the idea of like prefix sums, and of course dynamic programming. I think those are like the big things. There's plenty of resources online for like algorithms. Abdul Bari makes a lot of good algorithms videos, and he single-handedly carried me through that class. So that if you're like trying to self-study, that might be a good place to go. I would also recommend doing the LeetCode 150, if at all possible. Any recommendations on how to learn Python? At the moment, I'm in uni, but they don't teach you how to code. They expect me to just know. Yeah, that's kind of fair. Honestly, I didn't really formally learn Python. I pretty much learned it just by doing LeetCode problems initially. So I don't really have a great resource for it, but I think if you at least know I think that as long as you know like how to make variables, how to write if statements, how to write loops, and then I think most of the rest of the stuff can kind of come naturally just from doing LeetCode problems for the most part. And then through that you'll learn a bunch of the standard libraries. So things like the heap queue library, things like enumerate, the various different ways to sort, so on and so forth. There's one other comment I had about this that I forgot. Oh, the one thing that won't teach you is how to write libraries in Python. How to write libraries and what other libraries exist. So that I would just do a bit of Googling here and there. Maybe try to write a library yourself, maybe try to use some other libraries as well. And that should get you at least 80% of what you need to know with 20% of the effort. How goes it? Just finished a bunch of discrete math homework. Nice. I'm doing well. Discrete math was definitely one of the classes of all time. Yeah, I think that sentiment is a pretty accurate way to go about it. I haven't been formally learning C++. It's just been kind of going through this project honestly, and learning things to sort of solve my solutions. It's I watched a couple of Coding Jesus videos a month ago, and that's how I learned about smart pointers. And then I was even just a couple streams ago, you can go back. I was I was implementing the function, I think up here. It was in front end, HR to MIR. So if we go back to here, it's this little step here, which turns this into this. So it'd be this arrow. So I was going through that, and I was running into a lot of issues just with pointer ownership, because I was making a copy somewhere, and that invalidates a bunch of pointers that are stored in the memory representation itself. So the way I got around that was just using smart pointers. So unique putter. So I use unique pointers, and that completely solved my issue actually. And in the process, I learned a lot about them. So it's just the fastest way to learn anything is just to use it, honestly. Just jump straight into the pool, just dive into the deep end. There's this one saying that I read so long ago, and it's shaped my thinking a lot. It's the master has tried more times than the apprentice has failed, or something like that. The master has failed more times than the apprentice has tried. So I'm still trying. I'm trying as much as I can right now. And if I fail, that is just part of the learning experience. Keep going, bro. Best of luck. Thank you. I like it. I think a lot of the concepts help with developing creative problem-solving abilities. The second I tried to build a Python project instead of watching a YouTube video, that was the moment I started to learn. Exactly. That is always how it goes. You're cracked to sell. Lots to learn. So much more ahead of me. The fact I don't really... Maybe I'll call myself cracked once I know how loop optimizations work, but until then, I feel hesitant to give myself that title. Yeah, pass manager. Let's call this pass manager underscore manager. Let's do that for now. Yeah, let's do that. How can I deal with toxic Discord servers? You can approach this problem from like a action or avoidance sort of perspective. You can either try and get someone that has like power to do something about it, or you can take the approach of trying to disengage with it. So we're gonna make passmanager.h, and then we're gonna make the C++ file. Yeah, this seems roughly correct. Yeah, let's do that. I don't know what the interface for this is gonna look like yet. Let's just throw in the usual boilerplate. Why Windows though? Because there are still... so my laptop runs Arch. My dot files are like public, but there's always a little bit of an ember of a Valorant addiction that always sticks around. And just in case I need to scratch that itch, I am on Windows, unfortunately. So middle end MIR, and then we want to import, I guess, everything relevant from here. Currently trying to figure out how to schedule external API requests to update DB without making a complete mess. Yeah, that's kind of always how it goes. I think as long as... I think there's like the whole, I forgot what it was called, but there's like the notion of I think it was called a transaction, that, I think that at least worked for some of the stuff I worked on. I assume like you know it exists. So presumably it also doesn't solve your problem, but hopefully that at least like helps in some way. Also, so we have pass manager. I should probably just make this pass. Pass. No, we should rename. We should save this first. Yeah. Oh, I made a mess. Oh no. So we want pass. Yeah, okay. So on a pass manager, we want a generic pass, and then from there we can like, we can start figure things out. Why is Windows bad for coding? It's not necessarily good or bad. It's just like it misses. I guess like people in general are just more comfortable with Unix-based environments. Like a lot of the utilities that are offered with macOS and Linux are just missing because PowerShell is a mess. One of my friends, shout out Akash, he programmed on PowerShell for the longest time. Crazy guy. He switched to Linux like half a year ago. We set up Linux on our laptops together. It was like kind of funny. We like set aside a whole day for that. It was enjoyable. But since then, he has just been a 10x engineer from there. He like his coding expertise is just like shot up. Just like it's just increased at like an exponential rate. It's crazy. So not to say that like Windows is bad or anything, but people just generally enjoy the utilities provided by Unix environments more frequently. My jobs are not all or nothing, so I don't think I can implement that. That's fair enough, yeah. Then I guess you just have to be like really careful with state. So we also want pass.cpp and then pass.h, presumably. I'll figure out what goes into those as we go. So, let's... Okay, we were starting with pass manager. So namespace, middle end, and then what do we want? Do we want a pass manager object, or do we just want like run passes and it takes like a list of pass? I feel like I've been leaning into the object-oriented side more frequently than not, so I think I will keep doing that just for consistency, but I think base llvm does this as well, or just like llvm. I think I made a pass manager in here before. If you weren't with me for like my first 20 days of this journey, I followed llvm's like first language front-end tutorial, and there I worked with like actual llvm internals. I think I made a pass manager, right? Yeah, I did do that. Oh yeah, there's also pass managers at different levels, I just realized. Let's see. Module versus function passes. LVM. Okay. This might be interesting for me to read, because I also have things sort of at these three levels. Yeah. So LVM has these different levels. A module is made up of functions, a function is made up of basic blocks, and a basic block is made up of instructions. I kind of do a similar thing. But what goes in where is the question I need to figure out. What is the advantage of HR if all the passes are run on MIR? It just makes it easier for me to manage the code base, I guess. It's sort of like a, how do I explain it? It's like when you pre-bake a pie crust, you know? Like, you could theoretically get away with not doing it, but it just makes the steps, it makes the task of getting from point A to point B a little bit less complex. Sure, so that makes sense. Okay. I feel like I could simplify this more in theory, but that could also be a naive assumption. Explain LLVM. So LLVM as a whole is like a giant infrastructure project, and that handles like, take this sort of like idea I have here of like the 3 stages, and like the LLVM core is pretty much like just this middle end alone. And you might have like heard of some of the other elements. Some people also refer to LLVM as including like the backend stuff as well. But the core is pretty much just like this optimizer. And then from there, people write different interfaces to and from it, I guess. If you've heard of Clang, like the compiler, that is based on LLVM, and that refers to this, their version of the C to LLVM IR pipeline. That's like the very short version. There's also a lot of other stuff it provides. It also provides like the static analysis stuff that I have in llvm, providing like diagnostics and like checking correctness as an example. How impossible would it be to implement it from scratch? Well, it was made from scratch, so it wouldn't be impossible. It would just take a lot of time. I suppose I'm also kind of doing my own version of it in a sense. Okay. Yeah. So what passes are function passes and which ones are... Oh, it's a dragon. So which ones should go on which level at least? Oh, that's really funny. Okay. Okay. And this is actually a very important PowerPoint to read. So analysis passes. This is like the distinction I was trying to explain before. This like computes information without modifying it. Okay. Sure. One analysis pass may use another analysis pass as a result. That makes sense. Are you doing type checking pre-HIR? I intend on doing it as I generate it, I guess. Because that will also handle like typecasting. Actually? Yeah, I think... I'm not sure yet. I'm kind of at the point where I only have one type, so... that's a problem for future me to figure out. But the idea is hopefully I can delegate responsibilities between the two in a way that reduces the amount of work I need to do. Interesting. Yeah, so analysis passes, yeah, that stuff. Transform passes. Operates in place. Must leave it in a valid state, so you can just chain them. Can depend on analysis pass results, and potentially can preserve results. Interesting. Yeah, the default is to invalidate. Interesting. Here's a new subset IR. Yeah, okay, fair enough. Okay. So we can run multiple passes over a unit of IR. We can decompose it into smaller units. That makes sense, roughly. Pass manager builder. Wait, let's scroll back up. Or is this where the pass manager lives? Yeah, okay. So this is like the core idea in theory. So then, what is happening here? This is a... Okay. Oh, we're using templates, I see. This is hard to read, I can't lie. Oh, I need to learn about templates at some point, I just realized. Okay, that might be a week in and of itself. Maybe when school gets like really insane, I might just spend a week learning about templates. Okay. It's a vector of unique pointers to function pass. Okay. Sure. Yeah, this seems like straightforward enough, at least. Concept model. Sure. Yeah, and then we can do it like this as well. Okay. And this is like an adapter. So that makes sense, it looks like. Oh, I see. So a pass manager builder creates grouped passes. And just for clarification, this is the existing llvm infrastructure. Yeah, so this provides like pass presets, sort of, is how I'm understanding this right now. Yeah, so this is how -O flags, or O whatever flags exist. So like if you're compiling with like -O3, or like -ON, for example. Okay. That's an acronym. Okay. So there's 3 phases. There's cleanup and canonicalization. There's simplification and more canonicalization. And then target specific and learning. Okay. Sure. That roughly makes sense to me. Yeah, what's the big deal with canonicalization? What does this stand for? There's more than one way to do it. Okay. Many R forms are equivalent. Possible patterns of multiple operations are combinatorially many. So we just convert to a canonical form. Okay. The rabbit hole continues. Let's see. Sure, okay. Sure. Okay. So it canonicalizes and simplifies, which I guess makes sense. Yeah, that is one of the acronyms of all time. I'm definitely gonna steal that, but we will have to see when I end up using it. So we have cleanup and canonicalization. We've defined canonicalization. So then cleanup is just like it is clean. It is literally cleanup. Interesting. So we do SSA construction. This is one thing that I need to implement still. There's a whole side tangent here about SSA. If you're curious about this and you don't know, you should just look up static single assignment. The Wikipedia page is pretty good. We lower front-end friendly intrinsics and patterns into analysis friendly annotations. I see. And then we do more canonicalization. IPO. Compiler IPO. Inter-procedural optimization. Okay. So that's what that means. Just do that. Yeah, okay. Pure function. Okay, I see. Yeah, okay, that makes sense. So, just like, this is literally just like cleanup. And then, Lord knows what that is. Okay, well I haven't answered my own question, but I guess I have kind of learned a little bit more here. What is SCC again? Strongly connected. I see. Okay. So that's just a graph term. Oh wait. So yeah, this is fake then. Yeah. So then presumably this is something SCC. Call graph SCC. llvm CG SSC or SCC. Call graph. Yeah. Okay. That makes sense. Okay. So I have like argument promotion, attributes, inlining, so replacing a function call with the function body, per function simplification, outlining, and then, okay, sure. So per function simplification, okay. That seems like it makes sense. Phase ordering, inside out. Oh, I see. So it literally runs inside out. So from innermost loop outwards. Okay, that seems to make sense. And then we get into loop. Okay, yeah. So lowering, interesting. Interesting. Okay. More tuning. Okay. Does that pass? Okay. Yeah. So passes do things. Analysis doesn't change them. Transform does. Pass manager builder creates pipelines. There's 3 phases. Canonicalization is important. Okay. That makes sense. So then, from the pass manager here, oh boy. Oh boy, how do I even, where do I even go? Sure. Yeah, that makes sense. And then dependency-based scheduling. This seems like caching problem. That makes sense. A pass optimizes code before it turns into machine code. It's more general than that. It is just like, think of it as a, I guess like more broadly just a program or like subprogram, subroutine. Something that I guess is run across the IR. So then this gets into like the distinction between analysis and transform passes, I guess, on top of that. So like I guess like I make that distinction because like an analysis pass doesn't technically like optimize anything, but it provides information that a transform pass generally uses to optimize / transform code even. It doesn't even necessarily need to be like an optimization in air quotes. Okay. So historically this is understood as a scheduling problem, but then this is like annoying caching problem. This makes a lot of sense. Yeah, okay. So we can cache results of an analysis pass, which allows easy access across our units, and then the transform passes can invalidate them in theory. So yeah, so we add stuff to like invalidate a pass, and then we can get the result of a pass, and we can get the result of a cached pass. Sure, so then, oh boy, we make more of a mess. Okay, so this is just adding like preserved analyses, it looks like. Yeah, okay. So then we also have an analysis manager. Oh boy. And the use units of IR, what does this mean? Bidirectional? What's meant by bidirectional here? So lower level IR analyses can always be run on demand. Higher level cannot, because okay. And then invalidation must also be propagated bidirectionally. Oh, I just realized something I forgot to implement. Let me just write this down for myself. It just occurred to me I did not handle the case where, or when I'm generating MIR, I didn't handle if a function doesn't have a return. Or auto return gen. Yeah, because I don't have void types yet. And that's a really big problem. Yeah. I don't understand this slide though. I roughly don't understand it. So this does a lot of stuff, question mark. Yeah, I should throw this into ChatGPT. Explain this slide to me. It's in a llvm. Tap on the pass manager. Oh, that's okay. You know what? We'll see what it does. Okay, so that makes sense. Bidirectional. Oh, I see. That makes sense. Okay. Yeah, okay. Invalidation being propagated also makes sense. Yeah, okay. Why can't higher level IR analysis be run on demand? Mostly about consistency and potential conflicts in the IR state. What's an example here? Aren't they run sequentially though? Oh, because pipeline. I see. Okay. Okay. Sibling transformations. Suppose function f1 is being transformed and triggers a module analysis. At the same time, f2 hasn't been transformed yet. I see. Okay. I see. Okay, yeah. Because, like, dependencies, presumably. Okay, sure. I guess that roughly makes sense to me. Like, kind of, sort of, not really, but also just kind of. I'm getting pinged somewhere. Okay, so then function analysis manager module proxy. What's up here? Oh yeah, I see. So what is this? Okay. Yeah, Java type class names. Me when I make a singleton truck creation. Me when I make a singleton truck abstract factory decorator factory. Strategy. Okay. I'm confused what's happening here, at least. Oh, is this just splitting this up into the different levels of IR stuff? Or different levels of the IR? So we have function specific, we have like module, and there's like still adapters. Okay. Christ. Okay, this is a mess. And then this is like API use. Okay. Say no to automatic registration. Okay. Sure. Okay. Reusing passes. Compile time hit. Rebuilding pass pipelines. Obviate by avoiding the scheduling. Context. Okay. Okay, so this was like back when they were like first moving from the legacy pass manager, I think. I think this was like around that time, right? No, I think I'm very off on the timeline, but sure. Modules, functions, SCCs. No loop support. Interesting, okay. Okay, sure. That's all that stuff. So, did this answer any of my questions? Not really. I don't know what to put at what level yet. But I think I should probably reuse the similar approach of like caching, I think, is what I want to... One of the big things I've gotten from this, at least. This notion here. So, let me find where my list term lives. Okay. And so we can, let's get rid of that. Yeah. Where's my chat? There's my chat. Okay, so this is Pass Manager. I think I have a big Pass Manager, and that I feel like I don't need to engineer as much as this because I'm trying to be less ambitious about it. I could probably keep a list of analysis passes and then a list of transform passes. Yeah, and then I can bundle them in some fashion. So we want class pass manager, and then so we want passes to exist at least. So let's steal a little bit of stuff here. So let's write out this header. I think I will need both of these. And then class pass. I guess I can separate out analysis pass and I can separate out transform pass as well. Do that, and then if I need like a unified pass interface, I can make that a thing later. So let's make a vector of analysis pass. Analysis passes. I need to import pass.h. So we can do that. And then we can just copy this. So that seems like a good start. What else do we do here? Oh, there's another issue with mutating in place I need to think about, which is what happens if a pass fails. llvm handle pass fail. Okay, and then utility, okay. Okay, so I think I should, I'm getting full blinded by this. Let me just, okay, we figured it out. So what other utility passes are there? Okay. So then, I guess I should have a common pass interface then. And then, Then yeah, it's just a lot of graph/tree traversal. That's kind of the easy way to simplify it down. Or I guess the easy way to be reductionist about it, but Christ. This is difficult to engineer. I understand why people get paid big bucks for this now. Let's put a semicolon there at least. This feels arbitrary. Oh boy. Yeah, so we have passes. And what changes here? Okay. Okay, so we have a thing to like register pass, and we have a thing to invalidate. Invalidate a module? Sure. Let's just make this passes for now. Alright, let's keep it as is. I don't think I need to. We'll build it up as we get there, I think will be the plan. So we want to what was the thing called? The preset thing? Pipe yeah, sure. Yeah, we can like make separate static functions for that. Okay, so we want add pass. Transform pass. Oh, use T. And this needs to be void. Yeah. And then do that. And just make these P even. Oh boy. And then we want void run passes on program, MIR program. And that's also P, that's really confusing. MIR. There we go. I don't think we need instruction in here, at least, if we're defining paths separately. Okay. Okay, this is this is already a lot to think about. Yeah. So let's get paths built. We could even actually take a break to try and implement some of this stuff at least. This seems kind of simplistic at a glance. So we want include pass manager. We need middle end pass manager. We want namespace. How do we proceed from here? Hi, I'm non-CS student here. Self-taught kind of Vim. Vim bumps, fair enough. What's happening? Next line, I want to subscribe. Yeah, please hit the subscribe button. I am building a compiler from C to some form of assembly right now. I have like this little diagram I drew. So the portion, so the idea is we have C, we have assembly, and then we have an optimizer. I've done all the stuff to go from C to get to the optimizer language, so now I just need to like make the optimizer a thing, pretty much. That's like the very short, very brief explanation. So we want, the constructor is implicit, so we have void pass manager, add analysis. Yeah, of course. Is this the hardest part of the project? I think it's the least defined, at least, because a lot of the theory in compilers, from what I've read, it focuses more on the actual passes themselves rather than the logistics of running them. Like all the front end stuff is like kind of well defined. I just need to like figure out what goes where. All the back end stuff is also pretty well defined. There's just a lot of algorithms. The middle end passes themselves have also pretty well defined algorithms, but it's just a little bit of engineering that I need to kind of wander out into the void alone for. So we can actually let's make a macro 0. Let's add pass manager. There we can change that to curly braces, and the macro norm, call the macro, there we go. How long have you been coding? New to your channel, what was your skill set? I've been coding pretty much since my freshman year of college. I've been doing like, I'm definitely still learning a lot. I don't want to undercut that, but so this should use a reference. But most of my experience has kind of just been like whatever school has thrown at me. So I'm definitely still quite fresh, still learning a lot. Yeah. I guess if there's any like specifics, I could probably speak better to that, but at a high level, I've written more Python than I have C++, and I am trying to change that. Ooh, this gets like scheduling here. I'll figure out the semantics of that after I implement these simple mutators. So we want to I could even just like use one unified add pass, and then if it's an analysis pass, I just add to that. Otherwise, I add to transform. But What to do? We can just be simple with this. Also, there is like some small formatting stuff that I've just realized. Like these single letter names are low-key kind of nice because I don't want to write pass each time. I might go back through some of my old code and do a little bit of refactoring. And I guess while I'm at it, I can refactor all of the front-end stuff to not use raw pointers and start using unique pointers. Let me make a note for that real quick. Oh, this pen is dying. So variable names and then front end. I think the amount of JS I've written has overtaken the amount of Python. Yeah, that's unlucky. My condolences. Yo, I'm also encoding from India. Welcome. Welcome to the stream. Welcome to the community. Do that, and then... Okay, how do we want to figure out pass scheduling? Each pass has required analyses. Ideally, we'd like to run each of them before. So we want to run analysis right before the transform, if possible. So that's a minimum, and then after each transform, we want to oh no, this is overcomplicating it. I can check the dependencies, or the analysis passes each transform pass depends on before running it. And then just there I can just rerun the invalidated ones. I see. So I don't actually need to like schedule. This is like literally what the PowerPoint said. How did I forget about it? Literally just a caching problem. Yeah. Okay. So then how is this managed in this at least? We have get cached result. And then we have a thing to invalidate. How do we invalidate? Okay. So I guess we can, for auto p in transform passes, make this a reference. I probably need like a basic run in here. What did they call this? Like run pass? ID. Okay. Just run. Okay, yeah, I guess that makes sense. So we want run. This is a void. Yeah. Void run. Just do this for now. I can figure it out more later. That's kind of just a common thing I'm saying at this point. And then we can p.run. We could probably... I don't think I need to distinguish between levels, at least for now. Although that would make invalidation a little bit less messy, huh? I understand why it's split across now, because if we only invalidate like one function, then we don't want to have to rerun the pass for like everything else as well, because that's like pretty expensive. So we should make this take a program. MIR program. I'm in high school. Can you suggest me a tech stack for getting really good? That's like a little bit of an awkward question because a lot of it depends on what you want to do, at least. Like for instance, like if you want to get into like system stuff, you need to know like C and C++, but if you want to do more like data science or like machine learning stuff, you'd want to like do Python. Hey man, you should join another stream where I'm quite constant, just subbed. You'll hear from me soon. I'll learn a lot from you. Thank you. I'm sure I will also learn a lot from you as well. Take care. But yeah, I think a good place to start at least is probably Python, because that's used pretty ubiquitously everywhere. Also JavaScript's like pretty simplistic to use. I think it's also useful to know. I think that's probably a good start for high school at least. If you wanted to, you could look into like some web frameworks like React, or whatever is like trendy now. I think like Svelte is the trendy one. I don't remember exactly, but React is like surprisingly the stable one now. Yeah, I think that's a pretty good place to start at least. I don't think you really need to know too much more than that for now. So we run the thing, and then let's see. So we want to check, or I guess like rerun invalidated passes that Q depends on. So you'd also need like required analyses in here as well. So we want a vector of analysis pass. So this is required analyses. This should be private as well. Vector analysis pass get required analyses. This is the function. There we go. Yeah. There are so many projects I want to do. Football analytics site is main priority, but there's so many you can choose from there. Yeah, I think RL is not a bad place to look. It seems pretty fun, and you can like, it's definitely like the most entertaining out of the 3 general schools of thought on machine learning, I guess. I think schools of thought isn't really the right term, but like, I guess category of machine learning. It seems like the fun one. So we have to rerun. Oh boy, how do we? Yeah, this is a little bit annoying actually. Maybe we could like have an enum that maps to specific classes. Yeah, that might be a good idea here, instead of just like a straight list of analyses. Yeah, maybe I will do an enum. That might be smart, but that might also just be like really troll. So, yeah, I guess we can add that somewhere. What does llvm do? llvm analysis pass. This is probably a good one to look at. llvm codebase. Have it here. Something about seeing an agent learning real-time scratches in my brain. Yeah, exactly. Like it's just like funny to observe, whereas like with like a classifier or like a regressor, you just stare at numbers and it's like cool. Sure. Fine. Let's see. I'm sure this is in lib, right? Yeah. Analysis. Alias analysis. Okay, so what's at the bottom here? Oh, there's like a, sure, okay. Yeah, this is it's quite the file. So it starts down here. Okay. So this is how it, so there's like a macro to register dependencies, but I kind of don't want to do that. Okay. So that doesn't really help me, but sure. I guess what I can do is I can make these pointers, I guess. So the pass itself should probably, the analysis pass itself should probably hold the state, I think. Yeah, so we can just like, and then we can keep building based on this design stuff. So this would have like keep state stuff, and then like bool is valid as an example. I think this would probably be important, at least. Pass result cached. Yeah, we can do that. And then we'd also need something to like register each of these with each other, then in theory. Yeah, so then we can like okay. So this, we wouldn't need this, I think. We want to register analyses. Void register required analyses. And let's just take a const vector now, const vector reference, because we're just read only at least. This is pass star. This is analyses. Oh, that's ugly. Register analyses. There we go. Now it fits nicely in one line. Yeah, we can do that. Yeah, run, we still need, obviously. We could probably even... We can do this at function level, we can do this at basic block level. And then I don't think we need it at the instruction level yet, but that is something we'll figure out as we go, I think. Yeah, this would make sense, yeah. Because if a basic block changes, we'd want to just throw it out, I think. Yeah, so we have that for now. And then this would need a void invalidate. So we want oh, and then we'd have to figure out register here as well, huh? Okay, maybe this distinction is a little bit unnecessary, at least in the pass manager itself, but we could honestly just make run, whichever run is called here, create the relevant, we could make it just like rerun the analyses. Gotta work on my project, so probably won't chat for a bit, but good luck with this. Thank you. Good luck on your project as well. What else does an analysis need? So we have is valid, we have cached results. Yeah, so we need invalidate for sure. We probably need like is valid. Is there an instance where we want to use an invalidated result? Probably not. So you can just It's not really a good interface for this we can really call, huh? Some sort of get result goes here, I guess. Yeah, this seems about reasonable. So we can just run like this. I'm going to change this transform passes thing. Change this. Make this a pass. And then I'll make a pass function or pass class. Did anyone else get clicked by roadblocks? Oh, that usually happens, from what I've heard. A lot of people do not have a great time with it. Okay. And then we can move these runners into pass as well, I think. Extends public pass. Oh, that's a thing? Anyway. We can paste that in. And then we can do this. This should be virtual as well. Okay. I can probably just comment these out for now. I'm not really worried about that level yet, at least. Get rid of this as well. Yeah, okay. So then the analysis pass itself handles it handles like caching. So then that's good. Type result. And then type get result. Maybe I make this a template or something. That might make a mess though. I'm kind of scared to do that. So we can just do that and then so then this has required analyses and then what else do we want this to have? I think this is fine, right? Yeah, and then this has a run, so it's fine. Yeah, okay. Yeah, and then the register is like it'll just be like a linear search through it, I guess. Oh, I guess maybe I should also have it automatically add additional passes. So maybe this shouldn't be const. Yeah. Yeah, that seems fine. And this should always register the same ones. Yeah. I might make a macro for that as well. I understand why it was done now. Yeah, okay. Sure. So then, yeah. The pass manager. We could probably get rid of this and just do generic add pass. Pass. Yeah. Is it possible to just directly add an analysis pass, like on as a standalone instead of it being like automatically added. Probably not, right? So much engineering. Inst count, sure. Call graph. Okay, these are like. So I recognize some of these at least. So what if I let's open up Godbolt. Let's try adding something. llvm add pass command line. So we can just clean, I guess. I guess I can't do it with Clang directly, huh? What does this do? Oh, okay. So then, can I just emit llvm and then can I output this to something? Godbolt add pass. Okay, well, that seems a little bit annoying for now. I'm just gonna assume I don't need to support adding analyses right now. Or I could just like explicitly register that in the thing for whatever reason. Yeah, I think I can. We can even just make this like transform pass for now. That's dumb. I'm making it pass. Okay. Dash F flags? Okay. Good comms. So we can dash F. Let's see, what do I want to add here? Oh, God. Passes. Where is the list? There's the list. Let's just throw in DA. Where's the output? No, I don't want a tab group. Let's throw in TSC. Hey. Oh, I see. Fair. Cling F flag. Full blinded. My fault. Dash F. Okay. Okay, so it doesn't look like it has just like straight up analyses addable, which is, I guess, helpful. Yeah, okay, well, I guess I will just add transform pass. Yeah. that. Okay. I see. That makes sense, yeah. So we can keep this for now. But then we need to change add pass, it looks like. Also, yeah, this doesn't really exist anymore. Are you a cat? I might be. Who knows? So then we want... This should be... This should take a unique footer of transform pass. Should also unique footer of analysis pass. Nah, you still have your brain, silly. This should take a unique pointer, I think. Yeah, this. Yeah, let's make this take a unique pointer. What's good, Niraj? Let's do that. And then this would need to be a unique footer. Yeah, okay. Yeah, okay. We can then... what's the compiler for? Are you making your own ling? This is from C to x86-64. But I'm also trying to sort of build some of llvm's infrastructure from scratch, from the bottom up. So we can... So we have add pass, we have run passes. Why is this mad? Passes. And then we move it back. Yeah, we might hit day infinity, but I don't... If that happens, then that sounds like I'm streaming a lot, which is not bad. Streaming's way more fun than I initially expected it to be. Do you prefer C or C++? I haven't written enough C proper to be able to gauge that yet. Currently I'm enjoying C++ a lot though. Like, it feels like what I'm writing is what is literally... It's like, it's very what you see is what you get, I guess. I suppose C would be similar in a way, but I also feel like I will miss a lot of the abstractions that it provides as well. So let me see that, and then... run is a private member. Oh, I see. Joking, you're gonna land one soon, good luck, bro, thank you. I mean, even if it wasn't a joke, it would be pretty enjoyable to stream for a while. Yeah, that fixes that, and then... Yeah, we can do that. And then the run should also... That should also handle that. Will we try Rust anytime soon? I've written some Rust actually. It was mostly unsafe Rust, which is the funny thing, but yeah, hopefully I get more chances to write Rust, because that was pretty enjoyable, and I feel like I will be able to make better use of the features it provides now that I have some like substantive C++ experience under my belt. Because like when I was writing it, I had pretty much written like 2 C++ programs in my life, so I didn't really know like what moves were. I didn't really understand like unique pointers that much. So like the features were like still cool in a vacuum, but I feel like I didn't have as much of an appreciation for them as I do now. So I think if I were to go back to writing Rust code, I think it would be very exciting and very interesting to do. Do I want to make a revalidate function, or will that just go into run anyway? I could probably even do this, even. I could probably just like address that here, and then I can deal with like dependency stuff later. So I probably need like get analyses. I guess like void. Actually, you can just like this will be get analyses. Yeah, that should be const, and then we can for auto a in p dot get analyses. We can just run, I guess. Run. We can I guess we just have a separate we can do bool is valid. Is that llvm? No, this is my personal config that I wrote from the ground up. We can change this to valid. Not a dot is valid. We want to run, or we want a run. And this should be this should be arrow mem. So we want to run on mir. Yeah, I didn't start with any pre-built llvm config. I wrote it pretty much completely from the ground up. I use lazy envim for the package manager, but I don't use the lazy vim config, at least. What are you doing right now? I am building out the optimizer for my compiler, and there's a little bit of infrastructure that comes with that. So we rerun invalid analyses, and then we run the thing. We can get rid of these braces. Actually, we can make it. We don't need this. We can just rerun if invalid. Void. We can run if invalid. So we already built the compiler. I have I've built the front end for it so far. So I've gotten from C down to this IR that I've made called MIR. And I just need to, I kind of just need to like figure out optimizations and then do the backend stuff, which I guess is like literally 2/3 of it, but we're slowly getting there. Where do you recommend learning compiler theory? A lot of professors share their slides online. I think those are generally pretty good. There's also like a bunch of books. I posted a link somewhere in my Discord if you wanted to take a look at that. But it's like it's a bunch of like the GCC developers reading list recommendations, sort of. Rerun if invalid. You can do that. Yeah, so we rerun all of the analyses that are invalidated, and then we just run that one. The compiler itself is written in C++, but the source language for the compiler is C. So I'm compiling C code down, but the compiler itself is written in C++. Okay, so this is that, and then okay. Okay, so then I think that's like the we need to figure out past registering. Yeah, if I were to support the whole C++ feature set, I would probably be employed by now. So that would be great, but unfortunately that is not quite where I'm at yet. Okay, so we want to add pass. So we want to Oh wait, I wrote a thing for this, right? I have register analyses, and that should, yeah, p.register analyses, and then this should take in analyses. Or a reference to that. No? Or .git. Right? Wait, what type is that? Why did I make it? This unique putter. So .git? No. Do these even need unique putters? Because there's like a clear notion of ownership already. This was a little messy. I don't think these need unique putters, actually. Take care, Niraj. Thank you for stopping by. Just do this, even. To temporary type. Oh, wait. Register analyses, this should take... Wait, what? Okay. This is a little confusing. So then let me reconcile these types real quick. So we have, it should be a footer, right? No, it should be unique footer. Yeah, that should be unique footer. So we can undo that even. Yeah. I'm missing a closing thing. Non-const L value. I can't move here though, that's the problem. The middle isn't an end? That's true. That is technically true. Wait, so what happens here? What? Wait, so why does that break? This doesn't. If I, okay, I thought there was gonna be some crazy C++ shit happening. I guess not. Okay. So then, yeah, that should be good. And then I will leave this, I guess. I can virtual this even. And then these I can just implement. And then yeah, that should be big chilling. I might need like a map at some point anyway. I don't know. We want to get switch name, get switch, we create future middle or pass manager. And then okay, that has everything we have so far. Okay. Man, look, I'm hungry. Yeah, let's get this finished up. I might end up making a map for analyses, honestly. That might be the least painful way to go about it. Yeah, okay. What's wrong here? What? Oh. Initial pass manager password. Oh, I need to claim format. Damn it. Try NeoGit, I prefer command line. Wait, this one here? These are the same file. Okay, sure. And then we can steal this. Okay. I've like played around with various llvm Git plugins. None of them have really done what I want to, at least. It feels like very frequently, like either I'm already like familiar enough with command line stuff to have a faster workflow directly through that, or there's like some really niche feature that I don't have like binds set up for, and I would still need to figure out something on the command line. The one I've used so far is Vim Fugitive, but I just haven't really had a reason to like use them. Like command line works fine enough for me. So yeah, let me just check that this branch was pushed properly. Yeah, let's. Sure. Yeah, looks like that committed properly. So it's kind of faster and it's easier diffs. Yeah, I mean, I guess fair, but I haven't really gotten to a point where I necessarily need to, or I don't really have too much of a desire to use a any Git plugin, at least for now. So yeah. Maybe I might like try out a couple new plugins when I decide to like rewrite my config after like native package manager comes out, but it'll be a while until then, I think. So yeah. Anyways, I'm gonna call the stream here today. I'm quite hungry. I haven't eaten dinner yet. It's like 9 o'clock. Thank you all for showing up to the stream. Make sure you like and sub. It really means a lot to me and it helps get my content out to more people. If you haven't already, you should join the Discord. The link is also down there in the description. That's the best place to chat with other members of the community and to get notified when I go live. And while you're down there, also follow me on GitHub and connect with me on LinkedIn. And if you know anyone that is able to refer me anywhere, please send my resume their way. Specifically like NVIDIA right now. So yeah, take care y'all, take it easy.